Hello everyone. Thank you for taking the time to join me today. My name is Jiayi Zhang. Today I'm excited to present on large language models to you. Over the next 15 minutes, I will guide you through the development and the impact of these advanced AI models, the challenges we face in their creation, and what the future might hold for them. We will look at the engineering methodologies behind large language models, discuss some key results from their implementation, and finish by exploring how these models are shaping different industries. First, let's begin by understanding what large language models are and what they are significant in today's AI landscape. Large language models are a huge step forward in artificial intelligence. These models use deep learning to generate text that sounds very much like human speech or writing. The key advantage of large language models is their ability to understand context and generate relevant responses, which makes them useful in a wide range of applications. These include chatbots, automated content creation, and design making systems. For example, chatbots like that use large language models are able to handle complex customer queries more effectively than ever before. Another great example is in content generation, where large language models can write articles, generate marketing content, and even compose creative writing pieces. This shows just how flexible and powerful these models are. The most recent interactions, such as ChatGPT 4 series, have pushed the boundaries of what large language models can do even further. Now, let's explore how transformer models helped drive this change. The successes of large language models wouldn't have been possible without the introduction of transformer models in 2017 by Varvani. This model was a game changer in how we handle natural language processing tasks. Before transformers, models like RNNs and LSTMs were used, but they have limitations. For example, RNNs and LSTMs could only process text step by step, which slowed down training and made it difficult to handle longer sequences of text. Transformers, on the other hand, introduced the concept of self-attention, which allowed the model to look at every part of a sentence at the same time. This breakthrough made it possible for models to process much larger text more quickly and accurately. Self-attention was especially important because it allowed the model to understand the relationship between distant words in a sentence. Sometimes earlier models struggled with. Transformers now form the foundation of all modern large language models, including GPT-3 and GPT-4 series, enabling them to generate human-like text, translate language, summarize information, and more. Now that we understand the impact of transformers, let's talk about what has driven the rapid growth of large language models. The rapid development of large language models has been driven by access to large datasets and advancements in computing power, particularly through high-performance GPUs and TPUs. Training these models requires enormous amounts of data and computational resources, and it's no exaggeration to say that without these advancements, large language models wouldn't be where they are today. But with these advancements come challenges. Training large language models consumes massive computational resources, which can be expensive. Moreover, there are ethical concerns particularly related to bias in the data that large language models are trained on. These biases can unintentionally get baked into the model, leading to unfair or biased outcomes. Despite these challenges, large language models have demonstrated significant success. For example, GPT-4, which has over 170 billion parameters, is one of the largest and most powerful models to date. This has allowed it to generate more accurate responses and handle more complex tasks compared to GPT-3, with a 15% improvement in benchmark tasks like language translation and summarization. These advancements have opened up new possibilities in fields like healthcare, customer service, and many more. Next, let's dive deeper into how large language models are being used in different industries. Large language models are finding applications in a wide range of industries. Let's start with healthcare, where large language models are helping professionals generate medical reports with high accuracy. For example, one study found that large language models generated medical summaries were 85% accurate when compared to human-generated reports. This is a huge step forward in reducing the workload of healthcare professionals, allowing them to focus more on patient care. In customer service, large language models are used to create chatbots that can handle customer queries 24 hours per 7 days. These chatbots are capable for understanding complex questions and providing accurate responses, improving customer satisfaction. Additionally, they reduce the need of human intervention, which helps companies save costs. Education is another area where large language models are having a big impact. Large language models are being used to create personalized learning plans and provide students with instant feedback on their work. This allows for more adaptive learning environments, where students receive the help they need exactly when they need it. All of these applications demonstrate the flexibility and power of large language models, making them invaluable tools across multiple fields. Now that we have seen where large language models are used, let's take a step back and look at how they were developed. Before transformers, models like RNNs and LSTMs faced serious limitations when it came to handling long sequences of text. One of the biggest problems was the vanishing gradient issue, which made it difficult for these models to remember earlier parts of a sequence. This led to poor performance on tasks that required understanding long-range dependencies, such as machine translation or text generation. The introduction of self-attention mechanisms in transformers solved this issue. Self-attention allows the model to focus on different parts of the input sequence, making it easier to understand the relationships between distant words. This breakthrough allowed large language models to process much longer text and perform better on complex tasks. Performance metrics such as perplexity and BLEU skills improved significantly after adopting the transformer model. For example, when comparing transformers to earlier models, perplexity decreased by 20%, which is a clear indication of how much more efficient these models become at understanding language. With this advancement come new challenges, especially in managing the complexity of the system. Let's look at how we tackle these challenges. Developing large language models is an incredibly complex process. It requires collaboration between large teams of data scientists, engineers, and domain experts. To manage this complexity, we use tools like model-based system engineering, which helps us organize the different parts of the model development process. Tools like Git and MLflow are also critical, and managing the version control and experimentations of large language models. Since these models are constantly being trained, tested, and fine-tuned, keeping track of the different versions and ensuring reproducibility is essential. Without these tools, the process would be chaotic and prone to errors. In addition, the sheer amount of computational power needed to train large language models presents another challenge. We need to ensure that resources are used efficiently, and managing these resources in distributed computing environments require careful planning and optimization. With such complexity, ethical and privacy concerns also become more important. Let's look at how we address these issues. One of the major concerns with large language models is the bias present in the data they are trained on. If the training data is biased, the model can produce biased outputs, which can have serious consequences in areas like health care or legal decisions. Addressing these biases is a key challenge for large language models development teams. To tackle privacy issues, we use techniques like differential privacy, which allows us to train models while ensuring that individual data points cannot be tracked back to specific users. In healthcare datasets, that reduced the risk of data breaches by over 95%, which is crucial for complying with regulations like GDPR. By incorporating these techniques early in the development process, we can build models that are both effective and ethical. Finally, let's talk about how we manage the risks involved in developing large language models. Risk management is a key aspect of developing large language models. One of the biggest risks is data security, especially when working with sensitive information like healthcare data. To mitigate this risk, we use encryption to protect the data during both storage and transmission. Another risk is model bias, which can lead to unfair or discriminatory outcomes. We address this by training large language models on diverse datasets and using techniques to minimize bias during the training process. Regular testing this is also important to ensure that the models continue to perform fairly over time. Compliance with legal regulations like GDPR is another critical aspect. We work closely with legal experts throughout the development process to ensure that our model meets all regulatory requirements. Now, let's end with some final thoughts and look ahead to the future of large language models. In conclusion, large language models have transformed industries like healthcare, customer service, and education. They have shown remarkable flexibility and power, but we still face challenges in managing their complexity and ensuring they are used ethically. In the future, I expect that we will see large language models become even more efficient. With better methods to address bias and improve scalability, the next big step is to make these models more ethical and responsible while continuing to push the boundaries of what they can do. Oh, that's all my presentation today. Thank you for your attention. In our final presentation, we will explore more specific examples and discuss future advancement in large language models technology. I'm looking forward to sharing more with you.